Hi, everybody. This is Andre with Hillsborough County Public Libraries, and today on Tech Topics, we're going to be going over Tinkercad. Tinkercad is if you watched our last Tech Topics last month, you might be aware of what Tinkercad is. We briefly touched on it back then. It's pretty descriptive with its name, but we'll get into that. Uh, Here we go. All right. So Tinkercad, what is it? How does it work? How it's used and features to look for. We're predominantly going to focus on what Tinkercad's useful for. Something to go over is that CAD, the CAD part of the name, it stands for computer assisted design. And it's a specific type of software that we kind of went over last month in our CAD series. But we're going to go a little more in depth about what specific version of CAD Tinkercad is. All right, so what is Tinkercad? So Tinkercad is, like I mentioned, a computer-assisted design software. It's not quite as in-depth or complex as some of the other offerings that are out there. It is primarily browser and app-based, so you can actually just find an app on your iPhone or your tablet and just download it straight to there, the Tinkercad app, and you can start messing around with things right there. There you can go to your browser, Chrome, Safari, Firefox, and just go to the website and sign up there and start browsing away. From there, Tinkercad offers the ability to use and create kind of like 3D objects with templates of volumetric shapes. There's a specific word for this that you'll see in other CAD software. It's typically called a primitive. But for now, just kind of focus on the fact that they're templates of volumetric shapes. So like cubes, prisms, cylinders, spheres, cones, stuff like that. To kind of get your mind to wrap around messing around with something in a 3D space outside of, the physical world. So the way that you would manipulate these things, you can create other objects by stacking, combining, or subtracting shapes. We'll get more into that later, but basically that's what you're going to be doing. It's kind of like building blocks or Legos. You just kind of stack on stuff or remove stuff, and you kind of make your shape from there. Tinkercad can render in 2D and 3D objects, although it's not necessarily true 2D. We can get into that a little later, but for the most part, you just need to know that it renders both. 2D is more of an approximation, 3D is what it's actually rendering. And finally, basically, whenever you work with Tinkercad, if you're exporting or saving anything, typically it's going to export into one of 3 different files, and those are SVG, .obj, and .stls. SVGs are more like they're more specific to the 2D renders. Kind of useful for laser cutting, or if you guys have seen them before, a Cricut or a silhouette cutter. They kind of cut out paper based off of a flat design. Comparatively, .objs and .stls are more useful for 3D actual 3D objects, and they're more typically seen in 3D printers. You would upload like a .obj or .stl, and it would just print from there after creating the G code for printing. From there, we're going to talk about how does Tinkercad work. Tinkercad works, like I mentioned, there's a workboard, and you basically just drag and drop these volumetric shapes into the space, stack them, combine them, subtract them. And basically through that work, you create a design. Whether or not that design is anything of particular use, that's kind of up to you, depending on what kind of task you're up to. But that's kind of the general idea of it. You'll be using these volumetric shapes to kind of define something. The way that Tinkercad does this is by using vector graphics. Once again, we kind of went over this last month in our CAD tech topics. These vector graphics are basically mathematical representations of very, very, very precise lines. So basically, because we're working with computer-assisted design, the computer is basically taking this shape that's predefined, which makes things a lot easier for the computer, and basically it's pinpointing precise coordinates on this 3D plane to give a very, very, very clear-cut and very, very defined shape. because the math for it's so precise, it stays that shape regardless of, or it holds that resolution regardless of what you do to it. It's probably the best way to put it. As mentioned on this slide, because of this very, very exact precision, these objects can be scaled up and down without losing any definition. Basically, what that means is that you can take one of the predefined shapes, click on a corner, and make it grow. You can like drag it so that it grows taller, grows smaller, change the different dimensions of it, the proportions of it. But because once you let go and because it's using those vector graphics, the computer basically calculates the precise algorithm and mathematic chain that would basically define a very, very exact version of that shape, and will keep that exact version of that shape from that 3D workboard that you're working on your computer into any physical space that if you decided to actually like print it or something like that, it would keep the same. Hopefully that didn't dissuade most of you or confuse. We'll get into it anymore. If you have any questions, I'll be happy to answer them at the end. All right. So what can you do with Tinkercad? So as I mentioned, it's not the most complex tool. There are a few things that you can't do with it compared to other programs. But the very good thing about it is that it's a very good learning tool versus a working tool. What that means is basically it's very useful for understanding how to navigate a 3D environment when you're building things in it, but it's not particularly good if you have a very specific or intended purpose for it. So as we mentioned last month, there are a wide bevy of different CAD software out there, and they're all used for different industries, different tasks, different things like that. Tinkercad, on the other hand, is very good for learning. So what you're going to be learning on how to use it is for 3D model manipulation and basically like standardized gestures. So what you learn in Tinkercad would be applicable to most other CAD software like Blender or AutoCAD or LibreCAD. You'd basically be learning how to manipulate an object, turn the camera, stuff like that. And those things would translate across most actual software. Now that we've gotten those very general details out of the way, I'm going to show you how to sign up for Tinkercad. So what you're going to do is go to Tinkercad's homepage, and you're going to click on Sign Up in the top right, I believe. From there, you're going to click Sign Up. You're going to go to Account Type. It's going to show you two different types of accounts. There's going to be like an educators and students account, and then there's going to be like a personal account option. Tinkercad partners with a lot of education resources in schools to provide lessons on how to actually use these resources. If you have access to that, that's great. You can sign up for those right there and then. But if not, you can always just create a personal account. This will be translatable to both the browser version and the app version. So if you sign up for one, you can use it on both. So we're going to click create a personal account. From there, it's going to ask you for a specific email or to sign in with another type of account. Like most other websites, you can sign in with just a Gmail account, an Apple account, a Facebook account, I'm pretty sure. Personally, I'm just going to use sign up with email. We're going to click on that. All right, so once we sign up with a personal account, it's going to ask for our country of origin and our birth dates. We're going to provide those. If you don't feel like providing them, you can always change them. I don't believe there's any restrictions regardless of what you choose. Just make sure that typically most websites like these require you to have a certain age limit. If you need your parents' consent, please get it before you actually sign up by yourself. Right. So once you supply the country and birth dates, you're going to click next. And then after that, it's going to ask for a valid email and a password. You're going to provide those. Make sure that you write them down just so you don't have to, you're not locked out of your account after the first time. You're going to click agree to the terms and services and then click create account. If everything goes okay, you should get an actual a results page on the other side of that create account button. It's going to tell you that this account is good for most other Autodesk accounts from here on out. So you can actually use some of their other software and resources. They do charge for some of those resources, so please be aware of that. But other than that, if you're just sticking to Tinkercad, you should be fine. You can click done, and then that should take you to the actual dashboard. So once you've signed up, I'm going to show you what the dashboard to Tinkercad looks like. Hold on 1 second. Your first time signing into Tinkercad, you should see this homepage or this dashboard. Because I've kind of tinkered around with some things, there should be, it's kind of missing some stuff, but there should be a button right here to create a new design, and there should be a list of other tutorials to go through. I'll go through one of those in just a second. Some other things that are notable on your dashboard are that there are lessons for learning how to mess around with circuitry and code blocks. These are useful in the long-term kind of prototyping of objects and mechanics. In summation, Tinkercad offers a lot for, developing inventors, I suppose. So if they wanted to or had some interest, they can learn how to do these things. But for now, we're just going to focus on the 3D designs and manipulation. Also at the top, it's going to show you what's new in Tinkercad. There's classes, there's different contests that are going on, and in some cases, they even update some of the things that you can do in the actual workboard, like right here. Don't believe it's actually saying it right here, but they're advertising that you can actually add physics to some of the stuff on here now, which is kind of cool. I'm going to collapse that real quick. Up at the top here also, you have a quick bar for tinkering with 3D design, circuits, code blocks, your sim lab, the app, and Autodesk Fusion 360. This is kind of like a step up from Tinkercad, but it's more specific to like educational programs. I believe there is a free version, but it's only available to students of specific schools. You might have to pay for it if you're interested. Likewise, up here at the top, you have your gallery. You have projects, you have classrooms. So like if you were in part of one of those classes, you can go here and sign up for the actual class. And then resources, Tinkercad blog, tips, tricks, learning center, lessons plans, just a wide bevy of resources just in case you haven't gotten enough from actually just messing around with stuff. You can always just kind of browse and see what other things other users and other, I guess, educators have offered Tinkercad in the meantime since its inception. All right, so quickly over here. Oh, also quick detail. Once you actually mess around with some of the tutorials, they will show up in the tutorials tab over here. Because I've only messed around with one, this is the only one that's available. I'm gonna go back to designs, and I'm gonna click on this also. Oh. Once you click on an object or a project, it's gonna bring up this kind of dashboard screen. It might take a little while, but it's loading the actual 3D object here. You can click view in 3D and you can manipulate it with like a camera from here. You can also upload an image, change the copyright for it, copy a link to share in a classroom, or you can just download it. Like I said, you can download it in .stl or .obj or .svg. But for now, we're just gonna tinker this. And once I tinker, it's going to actually bring me back to this work plane. Let's see if I can. Okay. All right, so I might have messed around with it a little too much during the last tutorial. The tutorial is not actually popping up. But for now, let's go over some of the basics that you can do with Tinkercad. So starting at the top here, here's your toolbar. To the left here are kind of more your general things that you'll find in most editing software. There are buttons for specific actions. These include copy, paste, duplicate, trash, undo, and redo. If you've noticed, there are little hotkeys underneath. So if I did decide to press Control V or Control C, it would do the same option that I'm highlighting right now. Kind of the same thing. Like if you highlighted something in Word, Control C will copy it, Control V will paste it. Kind of the same idea. Over here is kind of your camera controls. They're not necessarily useful all the time. Like you might not use these. They're kind of just more for beginners. As you get more depth with it, you'll learn that there are actual physical gestures that might translate a little better as you become more of a power user. We'll go over those in just a second, but just to give you an idea, this cube right here kind of gives you an idea of what side of the object you're viewing on. As you can see, there are different parts that are highlighting as I roll over it. If I roll over it and then left click with my mouse, I can drag it and that'll change where my camera is in relation to it. Cool, right? If I click this little house, it'll recenter it at the home. All right, so same thing here. I can hover over these and get an idea of what it is. You can technically change the size of your work plane. However, in the process of doing so, you might overrun it with certain objects that might fill your work plane. So if you click this square right here, it'll zoom into what's on the actual work plane. Might make things a little easier instead of having to zoom and manipulate the camera to get back to where you want it to be. Below this are your zoom in and zoom out. As you can see, the hotkey for this is plus and the hotkey for zoom out is minus. You can do those real quick right here. And then this final one is isometric, or orthographic. Wow, that's a weird one. Orthographic flat view. If we do that, it's going to kind of force the objects to be at a 30-degree angle, which is kind of like a specific there are perspective drawings in a lot of other industries that kind of use orthographic visualization to kind of give an idea of how something will look at a specific angle, so you can kind of see something from more than one, I guess, perspective. This is useful for that. It just kind of changes how the camera views the objects. So going over those, if you have a mouse handy, the same controls for camera would be your right click. So if I wanted to, I can right click on the mouse and then I could manipulate the camera just like I did before. If your right click doesn't work quite as well, you can kind of do the same thing by holding control on the keyboard and then left click, and it'll also do the same thing. Pretty cool, right? So over here to the right, we're going to kind of get into some of the more complicated things or complicated tools that you can use. This first one, you might not use all that much. It's to toggle notes. If you see over here, I can click on this and it'll bring over like a little, like, I guess, a speech bubble. Depending on where I click it, it'll ask me to create a note. If I create a note, that'll leave it there. And if I click this, it'll just hide it. I can also just click back onto the note and shrink it, click back, click into it, and then just delete it. Over here, we also have a ruler. See, if you needed to measure things precisely from one another or anything like that, you can use that. Or if you needed to put in down another work plane. So say that you have something that you're building horizontally like this, but you also need something to build vertically. You can put a separate work plane to run vertically so that you have an idea of where something is in relation to the rest of the build. Kind of hard to picture, but if you manipulate it, kind of go over here, you can kind of see where I want to place it. And now we have a different work plane that I can run anything next to and kind of get an idea of how precise it is right next to it. Let's get rid of that guy. All right. So below these are our, basically this is like our toolbox. This is where you're going to be grabbing your volumetric shapes and dragging them onto the work plane. To start, you can kind of see these ones that are kind of shaded out. What that means is that they're kind of empty volumes. Basically, they're holes. So if I place a cube on the square right here, you can kind of see that blue circle in there. We'll get to that in a little bit, but I'm going to place my square right here. And it's going to bring up this context menu. I can change the color if I wanted to. If I wanted to, I can select whole, and that changes it into this kind of striped volume over here. These would be the same thing. If I wanted to, I can click back to solid. That'll change it back to an actual solid figure. I can change other aspects of it, including radius, which will change the actual like bevel to the actual object. How many steps, which would be it's a little more visually apparent, but if it had more shapes or an angle, you'd be able to see the actual like individual steps of that angle as opposed to just a straight line. If I wanted to change the length, I can. If I wanted to change the width, I can change height over here. So we're going to undo all of these. And if I click on the actual object, I can hide this over here. Click on the actual object. I can click onto any of these handles, as you can see on the object. It kind of repositions depending on where I'm actually looking at it from. But the one that I'm highlighted will turn red. If you get a good look at it, you can see that it shows me the measurements of the actual object, 20 by 20. I can click on this and then just drag it to wherever I want it to. Same thing with height. And same thing with some of these other arrows. So this one up here, I can click on it. I can change the elevation. It'll show me the elevation from the work plane at the bottom. It'll also give me an idea at the top how high up I'm going. And then these different arrows that are curved, I can click on those and then change the rotation of it. Let's do that. Let's go back. So these two other options over here, I can lock the object for editing. So if I didn't want to touch it at all or didn't want anything interacting with it, I can lock it like that. Or if I wanted to hide the object, I can click this light bulb and it'll just disappear. You'll notice that this other light bulb up here at the work tools shows up now that something's hidden. I can click on this and it'll just show everything else. All right. So for the rest of these tools, excuse me while I take a sip. So for these other tools, we'll need another object. I'm going to take a sphere right here. I'm going to place it right here. So if I highlight these two objects, some of these other options become available. This one right here is group. This one right here is ungroup. This guy is align. This guy is mirror. And then this guy is cruise. So basic understanding is that if I click group, these two objects now become a unified object, regardless if they're actually touching or not. So if I wanted to, I can grab it, just drag it all over the place. These two work in tandem with each other now. If I wanted to break them apart, I just click ungroup, and now they're two separate objects again. An even cooler thing that comes with that, though, is that if I wanted to, okay, so if I wanted to, I can just move this 3D object into here. You can kind of see that it's clipping through the rectangle now. If I wanted to, I can highlight the both of them again and actually group them together, and now it's one physical object. Cool. I can ungroup them one more time. I can click only on the sphere. I can change it to an empty volume. And the cool thing that happens with this is that when I combine the two together, it's going to turn that space where the sphere was clipping through the prism, it's going to change it into a divot that's in that sphere now. So basically by taking a empty volume, that sphere, and combining it with a solid object, the empty object basically carves out a hole of where it was. You'll use this to make more complex figures, complex shapes. If you're trying to prototype something, this is basically the kind of the meta for it. You're going to be stacking objects. You're going to be carving out holes, carving out shapes of different things to kind of piece together whatever object that you're intending to make. All right, so we're going to ungroup those again. I'll change you back into a solid so I can see you better. All right, so I can highlight the two of them again, and I can click on align, and you'll see these different lines show up. I can click on a specific object that I wanted these two to align to. So if I click on the prism, it's going to change where those actual lines are specifically pointing. And if you pay more close attention to it, you can see that it's actually specific to the actual edges of the object. So if I click on the middle here, it's going to align the sphere to the middle of this side of the prism. If I click on this middle, it's going to enter it to the actual middle of the prism right over there. Once again, I can click on this guy. I can change it into an empty sphere and then combine the two of them. And that's how you get more precise like combinations of figures, objects, stuff like that to kind of really develop your projects. If you look in through the hole, you can see that there is an actual sphere-shaped hole now inside of the prism. Kind of cool. I'm gonna break those apart again. Click on him, turn it into a solid one more time. All right. We're going to click on this object and we're going to go over mirror. Mirror is what it sounds like. If I click on this, it's going to show me a bunch of different arrows, basically showing what way it's going to mirror, what direction. If I click this guy, it's not quite as apparent. Let's see if I can find something a little more apparent. So yeah, I'm going to take this roof shape. I'm going to mirror it. And if I click on the up and down arrow, it's going to flip it over on its axis and it's going to point the pointy part downward now. Basically, you can do this from any angle. It's going to be more apparent on some of the other figures than some of the others. But basically, that's how you very quickly rotate an object in place as opposed to using the arrows to the side here. Right, and finally we have cruise. Cruise is kind of a weird one that they've added recently. It's kind of apparent once you actually drag an object out onto the workboard. As you can see, there's that little blue circle at the bottom there. That happens every time that you drag something out of the toolbox. Basically what it is that if I wanted to, if I rub it against an actual other solid object, it's going to try and place that blue circle along the physical edge of that object as opposed to clipping through it. If once I place it, it'll get rid of cruise, and then after that, I can clip through other things. But say I wanted to place this sphere on top of this upside down pyramid. Because cruise is activated as soon as I pull it out of the toolbox, I can drag it over here and then place it on top without any issue. Let's see, there we go. And it'll actually show me the work plane that it's actually using to place this object. Pretty cool, right? You can turn cruise on and off with objects that are out on the plane also still. It'll show you what your actual work plane is for that object. And basically same thing. You just drag it to wherever you need it to be, and it'll actually try to figure out what's the best way to place it along the other object's solid side. All right. So I'm going to set this up for something we'll see in just a few moments. But some other things to learn. You can import other 3D objects into here. You can export them. Same thing as before. It's .obj, .stl, .glb. These are usually for 3D printing. .svgs for laser cutting. And then if you wanted to, you can just export specific files for specific 3D printers. You can send it to other people or to other classrooms if you have a specific design or a picture that you wanted to take and send it to somebody else. And then up the top here, you can add somebody to join in on a design with you. You can go back to your profile. If we click on this block here or brick, it's going to change everything into kind of a Lego-esque filter. There's not much to do here, but it's kind of fun to mess around with. Same thing with over here with this pickaxe. It's going to turn it into blocks, which is more of a Minecraft kind of filter. Once again, not much to do here. It's just kind of fun to mess around with in lieu of the actual makerspace workboard, 3D design. And finally, we have the sim lab. So the sim lab is basically this very, very specialized version of rendering that Tinkercad can handle. It's a very new thing that's been added also. It's kind of cool. Basically, depending on how you set up your objects in the 3D design space, you can change the physical and material reactions they have to each other. So easiest way that I can describe this, I'm going to click this ball. I set it up earlier, just above everything else, so that we can kind of get an idea of how it works. If I wanted to, I can basically make that static. So once I actually started the simulation, it just stays in place. I'm going to reset the scene. I'm going to change it back to dynamic. You can also hide it here using that same light bulb icon. And same as before, I can change the color or I can change the material. So the material is going to change how the physics work in the sim lab. Basically, when you change a material, it's going to change how that object reacts in the simulation. I'm going to change it to bouncy rubber and change this into like a bounce ball. And then down here, it's going to tell you the actual like physical properties of that object in the 3D space. So when you run the simulation, this is all the actual like, these are the data points that it's using to run everything. So I'm going to take this, I'm going to change the material to, let's say, concrete. So change this triangle to concrete. I've changed this ball to bouncy rubber. And down here at the bottom, I'm going to press play and it's going to run through the simulation. So like before, I can use the camera to see what's going on. It's going to render in real time, or not real time, but it's rendering what it can right now. I can click reset and it sets everything back to normal. And click play again, and then it's just going to run through the same thing all over again. Once again, it's more of a learning tool. A lot of the stuff that you can build in here, I think they even showed it in one of the little like samples to the side over here, letting you know what you can do. You can set up some pretty intricate slides and stuff like that to run simulations through. You can make wheels. You can do a lot. But once again, it's more of a learning tool as opposed to a working tool. Once again. All right. So when you're done, you can click on here. You can change the object or change the name of your project if you needed to. So view it, I can change it to view it too. I felt so inclined. And if I'm done, I can click on the Tinkercad symbol over here, and it's going to take me back to the Tinkercad dashboard. When it does that, anytime you do that, it's going to save your project, and you're going to be able to see the actual results of it in this thumbnail right here. Once again, you can just click on Gearbox. You can click on the actual thumbnail. There we go. And it's going to bring up this object again, and it's going to show you everything that you've done, edited, created, stuff like that. You can always edit it on the fly, and you can always just mess around with it. And it's always going to save it for you. All right. If you guys are interested in learning more about Tinkercad, once again, there are resources on the website to learn it a little more. But we also do have LinkedIn Learning on hcplc.org as an e-resource. They do offer classes on learning Tinkercad along with other CAD software, including AutoCAD, Blender, and what is that other one? SketchUp. Those are a little more complicated. They're more industry specific. But once you get a little more grasp and understanding of how to use Tinkercad, they should click a little more easily. It'll be a little easier to grasp how to manipulate 3D objects and the specificities of these industries when using them. If you guys wanted to continue the experience, we have the Hive, which are offered at some of our larger libraries. If you wanted to learn more about them, you can go to hcplc.org/hive. Basically, some of these branches, we have recording studios, sewing machines, and classes on how to use 3D printers, basically some software. We have laser cutters, collaborative spaces, stuff that really get the, I guess, inventive juices going. These are offered at some of our branches. Make sure to look into them. They're a great resource if you guys are looking to do something this summer. And then finally, if you guys are looking to contact us, we're at hcplc.org/contact.
While you're digging that up, Andre, I'll let the folks at home know to remember to keep an eye on our library calendar for all these fun summer programs that are happening in branches and online right now. If you want to find some fun STEM or STEAM-based programs, just check that calendar. All of our summer programs and all summer information is on our website at hcplc.org/summer. Make sure you're signing up to track your reading as you go along. We have great prizes for kids, teens, and adults who track their reading. Some really, really fun, cool prizes. You know, if you like a Nintendo Switch or AirPods Pro or, you know, fancy stuff like that, make sure you're keeping a log of your reading, and we might see that you're one of the winners who won some of that fun swag.
Fingers crossed. You can contact us at hcplc.org/contact or 813-273-3652. If you guys have any questions, type away in the chat box and we'll try to answer them in the time that we have left.
Okay, so here's a question for you, Andre. So when you're working with Tinkercad and you're building these 3D designs, when you're first getting started, do you think it's more helpful to start from scratch and just build it up based on your imagination, or do you think it's easier to start with an existing design and to modify it to be more what you want?
It's a tricky one because, okay, so if you try to import a previously made design into Tinkercad, you're not going to be able to manipulate the specifics of it. Maybe just the proportions. So like if it's okay, say that you bring in like a 3D model of like a character that you like, and you wanted to manipulate it so that you can add like scenery or something around it. You're going to be able to like scale the 3D object that you imported into it, but you're not going to be able to do like specific actions like edit the face, edit the actual like way that it's standing, anything like that. It's just going to be an object that sits in place. If you wanted to, you can experiment from scratch and just kind of see where that will take you, or just kind of use it as a tool to kind of get your bearings in it, and then, you know, maybe learn a little more about the specifics of 3D model manipulation before you step up to that level. You can try and do like approximations to kind of get an idea of what's allowable in the Tinkercad workspace. That'll probably give you a better idea of what you can and can't do, as opposed to just having a project in mind and setting out to try and do it. Because I mean, like I said before, it's more of a learning tool than a working tool. So if you set about trying to do a specific project and then you hit a wall because you can't actually do it, that's probably going to be to your detriment than, you know, something that'll help you learn over time.
I think that makes sense. I think that probably makes sense why we should maybe start by signing up for a library orientation on 3D printing. I bet that would get us set on the right track for getting started too.
Mm-hmm.
All right, I think that's it for our questions in the Q&A session. Thank you so much, Andre, for bringing that expert attention to this program. I think it's going to help folks get started and jump in with learning Tinkercad so they can get the gears going for some of this more advanced CAD designing.
Always good to hear.
All right, folks, thank you so much for joining us for this Tech Topics. We hope to see you at our next session. Keep an eye on the library calendar for that, or go to hcplc.org/tech topics, and we will see you soon. Thank you, everyone. Thank you, Andre.
Thank you. And I'll see you later, guys.
Have a good one.